Okay, let's finish off the multiple choice questions. So number 16, the integral from 0 to x of sine of t dt. Well, the antiderivative of sine is the negative cosine of t evaluated from 0 to x. Let's plug in x minus, plug in 0. Let's see here, cosine of 0 is 1, so in the parentheses we get a negative 1. So it's negative cosine of x plus 1, which is the same as 1 minus the cosine of x. All right, 17 probably is the trickiest one on this study guide. So let g be a function with the first derivative given by g prime of x equals this integral dt. Which of the following must be true on the interval from 0 to 2? And we're trying to figure out if g is increasing or decreasing, and whether g is concave up or concave down. So remember this, that g is increasing wherever g prime is positive, and or decreasing whenever g prime is negative. We'll see about that in a second. And g is concave up whenever g prime is increasing, or concave down when g prime is decreasing. So just trying to think about it. If we know what's going on with g prime, whether it's positive or negative, whether it's increasing or decreasing, then we know what's going on with g, whether it is increasing and concave up or down. So next thing is this. What does that function look like? What do we know about it? And the thing you need to remember, e to anything is always going to be positive for all real numbers. So think about this for just a second. We have a function from 0 to 2. I have no idea what it looks like, and that's irrelevant in this case, because all I need to know is that it's always positive. So therefore, g prime.
Has the direction, bus students, please report to the buses, and Ben Skinner, please report to Mrs. Pope's room.
I'm just going to go over this. So g prime here is always positive, therefore g is increasing. And think about this area. As I start from 0 and we start moving, this area is increasing. So g prime, which represents the area from 0 to x up to 2, is always going to be increasing. Therefore, g is increasing, and the graph is going to be concave up. Okay. Again, I have a function that's always, always, always going to be positive. Okay, so therefore the area is always going to be positive, and it's always going to be increasing as we add more area, moving left to right. 18. Okay. If f is equal to this, then f prime of 2. So let's start by finding f prime of x. That would be the derivative of this. This is that fundamental theorem of calculus, part 2. So this just comes out to be x cubed plus 1. The square root of that, sorry. So that's f prime of x. And so f prime of 2 is the square root of 2 cubed plus 1, which is 9, or 3. Right, number 19, if g of x is an antiderivative for f of x and g of 2 is equal to negative 7, then g of 4 equals. So this is finding values of the function using the fundamental theorem of calculus. So we had a formula that looked like this, that f of b is equal to the integral from a to b of little f of t dt plus big F of a. So remember, f is big F prime, or big F is an antiderivative for g, or for little f, sorry. So this takes the place of our big F. This is our little f. So g of 4 is going to be, so this is our b value, therefore that's our a value, is going to be the integral from a to b, so from 2 to 4 of f of t dt plus g of a, which is 2. So the integral from 2 to 4 of f of t dt plus -7, and that gives us d. Okay, number 20. Let g equal the integral from a to x of f of t dt, where a is less than or equal to x, less than or equal to b. The figure above shows the graph of g on the closed interval from a to b. Which of the following could be the graph of f? So we did one similar to this. So I would look at the g prime of x as the derivative of all of this. And here again is our second part of the fundamental theorem. So these would cancel and we just get f of x. So if we want a graph of f, we need to look at the derivative of g. So the key features here are we're looking for a function that is approximately 0 at a, approximately 0 somewhere in between, and approximately 0 at b. So if we look at our graphs here, this graph is out, this graph is out, and a and b are good. The only difference between a and b is that a is positive first and then negative. So if we go back to our graph, the slope here is positive and the slope here is negative. So I'm looking for a graph that is positive and then negative. And that would be letter C. And then let's finish out with number 21. The graph of f prime, the derivative of the function is shown above. If f of 0 is equal to 0, which of the following must be true? So we know f of 0 equals 0. So therefore f of 1 would be the, well, let's see here. What is f of 1? If f prime, if this is what we're given, that would be the integral from 0 to 1 of f prime of x dx. So that's the area from 0 to 1. Since that's above the x-axis, I don't know what it is, but I do know it's greater than 0, which is f of 0. So f of 1 is going to be greater than f of 0, which means 1 cannot be true. So in each of these cases, we're just accumulating the area. So notice as you move from 1 to 2, we accumulate more area. Therefore, f of 2 is going to be greater than f of 1. We then take away area from that because it's negative. So we do know that if it mattered, we do know that f of 2 is greater than f of 3. However, how does f of 1 compare to f of 3? Well, notice the amount of area we take away is less than the area that we added between 1 and 2. So again, we added more area after 1 than we take away after 2. So that means the area from 0 to 3 has to be greater than the area from 0 to 1. So this case, 2 is the only answer. In the next video, we'll have the FRQ.